Okay, let's start to look at what is data warehousing. So what I kind of did was I took the reading from this week, and I sort of like wrapped it into my own take on that reading. And so this is a loaded question, because if you say process, I'm going to kick you out. But the most important asset in any organization is the organization state, right? And so, like, some people say, well, it's the people, right? It's the mountains of cash that they sleep on because they're greedy. No, it's none of that stuff. It's the data, because you know what? There is so much value in the data that organizations collect about their customers or their products or the way they do things that many organizations are just buried under a mountain. Think of a metaphor of somebody like with ones and zeros just piled on top of them. That's how most organizations live with their data. They're overwhelmed by it. And the promise of data warehousing is to help you become less overwhelmed by your data by empowering people to make intelligent decisions with it. So one of my things about why data is so important is, do you know your customers? Do you understand their needs? Can you figure out what products to put on your shelves, right? Do you know which products don't sell? Do you know where you're spending your money? Do you know how profitable you are? These are all answers that we get by looking at the data that we have. And well-oiled organizations, those that are very efficient with their data, can easily answer these questions. So the answer, of course, is no, right? Can you do these things without data? Nope. You can't. So this reminds me of a story. So if you think of fast food restaurants, okay, and there's somebody working the counter that sells you your hamburger and your French fries or your chicken sandwich, right? And if you think about that organization, there's lots of people that work in an organization like that, and they all have different informational needs. And so I like to call this the management food pyramid. That's a joke. Because when I was a kid, for you international students, the government forced this idea down our heads as kids that to get nutrition, there's this pyramid, and you should have a little bit of fatty stuff and a little bit of sugar and a lot of like bread and some cheese and whatnot. I don't know. I don't even remember it. That's how important it was, right? But anyway, there's this pyramid that exists in all organizations, and it works the same way. There's very few people up top that do strategic management. These are the EIEIO people, the CIO, the CFO, the CTO, right? Then you have tactical management, operational management, which is where many grad students get their first job. And then there's non-management employees, and these come in all different ranks. You could be a technical non-management employee. You could work in a factory. You could do retail. You could be working the cash register at a fast food restaurant. And so everybody's informational needs are different depending on the level of the organization. So at the bottom here, you might just say, it's all about the individual transaction, right? Do you want a shake? Do you want fries? You owe me $12. It's about the ins and the outs of the transaction, right? Not really thinking longitudinally about things. Like people that come to work every day in a restaurant probably don't say, are we selling more shakes now than we did last year? Those aren't the types of questions they ask, right? And so those are the questions that operational management might ask. They might say, well, should we put this product on sale because we have a lot of it? But usually operational management they look at a specific geographic area. So they're not concerned with what's happening, in China. They're only concerned about what's happening in Mexico, because that's their boundary. And this is like, sales people fall into this kind of category. Sales managers, store managers, or regional managers might fall into this category. So at the tactical level, this is where we start to break up the organization vertically. Like we might have people that are business analysts. We might have, like here at the university, we have people that are responsible for registration. We have people that are responsible for scheduling. So we break it up into processes, right? And then those people, they might look at larger trends, like, are we effectively using our rooms on campus? And the example I had is you might say, well, the demand for French fries in our China locations is up 200%. They might look at those kinds of numbers. And then look at the supply chain and then say, well, we need to buy more potatoes so we can make more French fries. You hope the French fries come from potatoes. Who knows where they really come from? And then customers who purchase fries are also likely to buy milkshakes. Right, those are trends, right? That's maybe you look at high level, very high level type issues, right? Dashboard style issues. So when you get a receipt, right? There's information on that receipt, and you know that the data on that receipt came from some kind of transactional database. And I've been kind of preaching this since last Friday, right? And these transactional databases, they're also called operational databases. And almost all of them that I've encountered are stored either in a data file, a series of data files, if they're on a mainframe, they're in data files, or they're stored in a relational structure, like Oracle 11G or SQL Server 2014 or one of those babies. And they're very normalized, right? One of the big no-nos in operational data is storing customers in two places, right? Or storing, having two product tables. That's a bad idea, right? You do not want redundancy. We spend all this time learning about data normalization and splitting our data out into more tables, because if you break down the table into its atomic level and really simplify it, then you don't have to worry about this problem where you add data and it's stored in two places and it's different in two places. And then you don't know which number to use, right? That's, in my job, I've seen accounting packages and payroll software and inventory software, all of which was not efficiently normalized and caused problems. And these are products that we paid, six figures for, and it's just, not efficiently designed. So there's a balance between over-normalizing and denormalizing that every developer needs to make. And the pro of denormalizing is that you have a faster speed, right? At the sake of data redundancy. So it's a trade-off between, how operationally efficient do you want to be and how much data do you want to store redundant, right? So there's no right answer is my bottom line. Somebody comes in here and says, I do everything to like ninth normal form or whatever made up normal form you want to make. That's not realistic, right? So there's a balance in there. Because if you go too far, now it's overly complex. I build websites and mobile apps on the side. And one of the things that I used to estimate for a customer how long it's going to take me is I first create a basic ERD and then come up with a number of tables. And because every table needs a create, a read, an update, and a delete process, right? If they have like a product and then you can schedule something, all these things take tables. And then I can estimate the amount of screens I might need, and then of course there's usually some complicated logic in there and reports and stuff. But it gives me a good idea. And so generally the rule of thumb is the more tables you have, the more complex your system's going to be, right? If you only have 3 tables, pretty easy, right? If you have 30,000 tables, it's a lot more complicated. These databases are designed for capturing data and not reporting the data, right? Especially longitudinally over time. And it's designed to support the operational needs. So transactional databases are complex. This database here, which you'll get familiar with, is called the AdventureWorks Bicycle Manufacturing. AdventureWorks is a fictitious bicycle manufacturer. They have 72 tables in the database for things like customers, and products, and parts, and locations, and employees, and sales teams, and this and that. It's everything you need to run the business. The Blackboard Learning Management System, which we don't use because we're using Canvas, so I don't know how many tables are in Canvas, but I know when I used to be the systems admin for Blackboard, there was almost 600 tables. Announcements, files. Every file that you upload, the file gets stored in a table. Information about the file gets stored in a table. And then when that file connects to an announcement, there's a bridge table in there that does that. Okay? So you've got announcements, you've got discussion boards, you've got threads in the discussion boards, you've got quizzes, which have questions, right? Think of all those tables. And then PeopleSoft, which we use to register for classes and all that stuff. There's over 40,000 tables. They have all sorts. They do all sorts of things. The table for credit cards, a table for alumni, a table for address, because you might have 3 or 4 addresses. So the address, your mailing address when you're here, the mailing address when you're home, the mailing address when you graduate. So I love this example because I just wrote this query. We're going through the process of doing accreditation for American Library Association, and I get asked to write all these data retrieval queries like, give me a list of professors who taught LIS students in the last 6 years and give me the names of the classes and how many people were in them. And so even writing some of these simple queries ends up being this tremendous amount of SQL. This is one select statement. It's not even the whole thing. I had to cut it off because it doesn't fit on here. This was written in Oracle. And in here you can see there's another couple of sub-selects and woo. And this is based on an operational data store, which you don't really know what that means yet, but what that means is it's not even the production tables, which are really normalized. This has already been denormalized a bit, and it's really complicated. And so you look at something like this and you say, how can the end user answer their own questions when it takes someone like me, look at this, join. Ah, is that crazy? You really write that? I did write that. Actually, this query is the source of the v_ist_students. This is the source. This is what runs when you run that. It's a big beast. So there's lots of issues with this. So the problems that we have here is that, not many people can do this. Okay? But there's lots of people that need questions like this answered. And you can see how difficult, time-consuming, and error-prone it could be to write something like that. It took me 5 business days to write that correctly and verify that it was right. And I don't even know if it's really 100% right. I don't know if I'll ever know it's right. Because how could I? So how do you deal with this kind of stuff, right? Running a query like that is very resource intensive. I hit the run button, I go downstairs, I chat with the guys, I come back up, it's finished. 5-10 minutes later. Some of these systems, it's not possible to query what you want because the operational data gets flushed, right? You can't store every single student that's ever gone to school here. You just can't. It's too many. So certain students that graduate, those people aren't in the system in a way that they can register for class. And that's why class registration goes as quickly or not as slowly as it does. Okay? You might say, well, it doesn't really go that fast, but it could go a lot slower if every single person that ever graduated was in the set of people that could register for classes and not just the people that are active students. Right? So the solution is the data warehouse. And all a data warehouse is think about it this way. Yes, it can be a relational database. It doesn't have to be a relational database. The way I like to look at it is it's really just data that is outside of your transactional system. It's a copy of that data. And it's been reorganized in a way that makes it easy for people to report or do their own analysis on the data. Right? So here's a really great example. Let's suppose we had this data warehouse and someone upstairs could say, I wonder which of these classrooms is the busiest classroom, the one that's booked the most during the day. Is it this one? Is it the one over there? Which one? It'd be a great question for them to ask and get answered without having to ask me to do it. Right? They might then kick it up a notch and say, I wonder if we can predict which classes use which classrooms. I wonder if there's a way to do that. Right? When you start to get into prediction, then you're starting to look at like data mining. You're starting to look at a different discipline. But data mining kind of goes hand in hand with the data warehouse because what the data warehouse does is the data warehouse is the foundation, and then the data mining is the walls. You can't have walls without a foundation, right? You need that. And so that's really the idea is that you can do data mining without a data warehouse, but then the first question you should ask yourself is why would I do data mining without a data warehouse? Because has anyone taken data mining or you're taking it, right? I don't know what kind of data sets you use, but in real data mining, you might run this over a couple million records and it might take you all day to do the analysis computationally. But then once the analysis is done, you don't need to do it again. So what better place to store the output of that than in your data warehouse? So your transactional databases are your data sources for your warehouse, and the data warehouse grows over time. Okay? It never gets any smaller. It only gets bigger. So when you estimate the needs of your data warehouse, you need to really think about how your data transactionally grows, because you know that none of those transactions are ever going to go away. They're always going to live in the data warehouse. And at worst, they might live in a couple places in the data warehouse. According to Inman, your data warehouse should be time variant, which means it should give you a picture of a point in time. So I can say, last February, boom, what did the world look like? This Tuesday, what's the world going to look like if I'm doing some kind of predictive analysis? I should also be able to see how data has changed over time in my data warehouse. The customer used to live over here, now the customer lives over there. Or this student was applied statistics major, and now they're a information management major. I should be able to see that. It should be non-volatile, which means it shouldn't change. Once the order happens, once you buy the hamburger and french fries, that gets put into the data warehouse. Let's suppose you say, I don't want this hamburger, can I get a refund? Do we change the order in the data warehouse? No. We add another row with a negative number in it that says it was returned, right? We undo it with another transaction, right? So it shouldn't change. There are some cases where the data changes, but it's very rare, and it's usually because the story hasn't finished yet. So I'll give you a great example. Let's suppose we want to build a data warehouse that tracks what students do, right? You apply, then you get admitted, then you enroll in your first class, then someday you graduate, right? I have to track you have to track the student over time, and the student is changing, or things are being added to the student. Milestones are being added to the student as you go through your lifespan. So that would be a very an example of a data warehouse where the data is manipulated. You wouldn't be changing the original when you originally came to school. You'd be adding things about the student as you went. Data warehouses are very integrated, and they're subject-oriented. So subject-oriented means that you can look at any given category and then get information about some data within that category. So you might be able to say, you can easily say in a data warehouse, if it's set up right, how much product did we sell in Florida? You should be able to answer that really quickly. Then you could say, well, how much product did we sell on Tuesdays? You should be able to answer that pretty quickly. And so subject-oriented, one subject, Florida, the other subject, Tuesday. I can answer both of those questions. I don't need anybody to write me a query. One of the magic behind this is that we need to take our operational data and get it into our data warehouse. That's called ETL. Okay? This is the most time-consuming part of building a data warehouse, is figuring out how to get your operational data out of its operational sources and then into a data warehouse. And then in the process, shape it in a way that's going to easily answer these questions. And this is not as easy as this wonderful picture depicts it. It's much more difficult. And we'll spend 2 weeks on ETL, and we'll spend a lot of time learning about it, but to master it really takes a lifetime. Okay, the data mart. So in the data warehouse, we build data marts. And data marts are specific problem-solving bits in the, I don't want to use any technical term yet, because we don't know them. So what your data mart does is it answers a certain category of questions. So you have a data warehouse, the SU data warehouse. One of the data marts might be enrollment. How do students take classes? Another data mart might be adds and drops. Another data mart might be scheduling. How do we schedule classes? Another data mart might be purchases in the bookstore. So when you think about organizations that have a good idea about how to use their data, they look longitudinally across data marts, right? So they might say, all right, we got this data mart that says who buys what in the bookstore, and then we got this data mart that says, you know, who enrolls in what class. Is there some kind of correlation between people that buy sweaters and take IST 722? Right? Those are two different data marts. But if you have an organized, if you have a data warehouse that is integrated, you should be able to do that pretty easily. It takes a lot of work to get there. Okay, so the data what happened was we recognized early on that there was a need to do this, especially when, you know, the CPU and RAM was not very good in our technology, and so copying data was essential to doing any query. Now you can do real-time querying of systems, and seldom people notice, but that doesn't mean it's a smart thing to do. And so we came up with the data warehouse. That led to better decision-making, which then led to this whole discipline of business intelligence, which business intelligence sits on top of data warehousing, and it's really like the application of the data warehouse. Again, the data warehouse is, think of it as a foundation, and then business intelligence is all the wonderful things that are inside the house that everybody likes, like the big screen TV and the surround sound, and the fact that you've got a phone, a home phone, all that stuff. Those are all the cool glitz and glam of the data warehouse. It's what people see when they use a data warehouse. What the end users see when they use a data warehouse is not the data warehouse. They're using some tool that's business intelligence related. So this is like a chicken egg issue with a lot of students. Is they're like, all right, is the data warehouse a component of business intelligence, or is business intelligence a component of the data warehouse? And honestly, you can't have one without the other. You just can't. Okay? You need to have some kind of data warehouse to do business intelligence, right? If you want to do business intelligence, you're definitely going to need to have a data warehouse. Okay. So let's go and give you a hyper-abridged example. This example is so abridged that if someone else who was an academic would walk in and see me do this, they would probably kick me out of here. But I like doing this because while it oversimplifies what's happening, you'll leave here and understand what we're trying to do. Okay, so here is a database with a bunch of tables in it. This comes from Northwind Traders, which is it's like kind of like a spice trading company. And you want to buy star anise, you could buy it, from Northwind Traders. It's a fictitious company, right? And they have customers and suppliers and products and orders, and all sorts of fun stuff, right? This is our operational database, which is pretty simple, right? Your project in 659 looked like this. Maybe there was a couple less or a couple more tables. All right. So when you want to build a data warehouse, the first thing that you need to do is you need to identify what business process or what business function you want to model in your data warehouse. Everybody likes to go for the low-hanging fruit, orders. Orders are something that we all understand, right? So in this example, I'm going to use orders. So when you identify the process that you want to model, like orders or maybe it's scheduling or whatever, you now need to kind of define it a little better. And by doing that, the first thing you need to do is identify what is the grain of the business process. And the grain means when I look at the operational data and I look at a row, what am I seeing? What does one row mean? And you might say, well, that's kind of trivial, and why would I bother to learn something like that? Believe me, that's the most valuable thing you can do to get the data warehousing right, is to know what that one row means. And so one row, one order means it's a product sold to a customer at a certain point in time. Okay, so I might go to Amazon, or, because I don't have spices in front of me, so I'll have to switch. And I buy this marker, and I buy this jug of water. Now, these might be on the same order, right? But what I'm defining as an order is this is one order, this is one order. Now, you might say, why would you do that, Mike, as opposed to just lumping them together? Anybody have an idea why? What would be, I want you to think about this term right here. Integrated and subject-oriented. What subject would I lose? What subject would I lose if I lump these two things together into one order? What can I no longer classify that order by? Product. By saying, hey, this, and this are all in the same order, right? I now lose the ability to flesh this out and say, how much paper do people buy? Or how many markers do people buy? Or how many jugs of water with ice in it do people buy? Not many. Right? So you have to think about that grain, because the more granular you get, the more subjects you can introduce into your analysis. Right? Those subjects we call dimensions. You probably heard that slip out of my mouth a couple times, last week and maybe today. Now I can use it liberally because I've defined it. A dimension is a category of data that we want to analyze our business process by. And the beauty of dimensions is that if they're done right, they're highly reusable. So a product is a product independent of an order, so that I can then use that product and associate it with something completely different, some other business process, if I want. Like maybe inventory procurement, okay, or supply chain. Then, inside your business process, you need to identify what are called the facts. And the facts are the things that you want to measure in your business process. So, what would I want to measure in an order? Don't look at the slide. I'd want to measure, how much you paid for this. Right? Now, how much you pay for this changes over time, right? Today, you may pay $3.99 for this wonderful Lexan water bottle, and then 6 months from now, it might be $8.99. And the amount of money that we capture goes with the individual order, because the amount changes over time. Right? Time variance. And then you might also want to capture quantity. Like, I bought 3 of these at the time that I placed the order. When I used to work in retail, there was a huge metric that we used. And have you ever heard of the word key performance indicator? You're going to hear about it a lot in this class, because that's a big part of business intelligence, is when you kick your business intelligence up to the next level, right? You build a data warehouse, you have improved decision making. Business intelligence is, KPI. And what KPI means is you understand your data so well that you have an idea of what good and bad mean, and you can measure it. We have KPIs for enrollments and wait lists. If the class doesn't have 15 people in it, that's bad. If the class is full, or 1 or 2 close to full, that's pretty good. If the class has more than 15 people on the wait list, that means we might want to consider another section if we have the capabilities to do that, if we have a place to put it, and if we have someone to teach it. The problem is always having enough people to teach it. The constraint is professors, because what you can't do is just say, we need another section of 722. I got a great idea. Let's just make another section and find someone in three months to teach it. You can't do that, right? You can't do that and have a good experience for the students, which is why I got bigger group. So does that make sense about facts and dimensions and the business process? The business process is the heart of it. You start with the business process. Think about what it means. Think about what you want your granularity in that business process to be. Then you loosely discover the dimensions. I want to look at this data by its product, or by employees, or by time. Time is always a dimension that we care about. And then we also look at our facts and say, what do we want to measure? And we want to make sure that these facts are additive facts, which means they roll up over time to a sum. So, for example, if I take order quantity for just water bottles, I should be able to add that up with a sum, right? If I got one here, and there's one over there, and there's one over there, and there's one there, and there's one there, there's 5, 6. I can add them up, cross orders. Order amounts, right? This one costs $3, that one costs $9, that one costs $12, add it up. When your facts are not additive, it's not a bad thing. It's just a little more challenging. We love challenges, trust me. Okay, so a little more challenging. Sometimes you don't have a fact. The fact is the fact. That's a horrible way of phrasing it. The fact is the idea that the row was added. The fact that it happened is the fact. A great example of that is, let's suppose I built a data mart to track attendance in class. The fact is that you showed up, that your butt is in the seat. That's the fact. If you're not here, that's a fact as well. But I don't want to add you if you're not here, right? So this would be an example of a data mart. So a data mart solves one business process, just one. And we'll have many data marts in our data warehouse. A robust data warehouse has several data marts, but then it reuses all the dimensions. And if there's an attribute missing from a dimension that another data mart needs, then you simply add that. You add that attribute into that dimension so that it's there. And so this is kind of like everything that we do in IT. It's an iterative process. You start with something, and you build it, and then you make it better, and you add something else more to it, and then you build that, and you make that better, and then you keep going. And then just when you think you've got it figured out, now you start to bring in some data mining, and then once you figure that out, now you start to build some kind of dashboards and high-end analytics and interact. Somebody's carrying around an iPad, they can browse right on their iPad what's happening, right? You're always taking it to the next level. But you got to start somewhere, right? And if you don't have a very good foundation, if you don't start at the bottom with this stuff well organized, it balloons into this quickly. It looks like that. Okay, one of the problems that I face right now is we don't have a very good data warehouse. We never have had. And so, while I have time, which is not very often, and it's not something that I'm supposed to be doing, but I recognize it's important. So as I carve out time, I'm slowly building something. And you will help me do that in this class. You'll help me figure that out. Because one of the challenges of doing it is you need to. It's just like anything else in IT, right? We spend all this time going down a dead end, but that doesn't mean there was no value in doing that, right? You say, "Oh, that was not a very good idea," but now I've learned that was not a very good idea, and I know better now, and I'm never going to make that mistake again, right? And that's just as valuable as actually completing the task at times. All right, so step 3 then is you create another schema. Right? This is in your data warehouse. This is in your transaction system. So this is like external sources in your SQL Server database, and then I might stage these into my own copy, and then in my DW I have tables like this. And this is called a star schema. And the reason it's called a star schema, if you look at this, right, this is in the middle. And on the outside are all one relationships, and in the inside are manys, right? So it's one to many, one to many, one to many, one to many. All star schemas look like this. If your star schema does not look like this, you're doing it wrong. You need to redo it. You need to rethink that business process until you make it look like this. Because this is the key to making ad hoc queries that an end user can do without you, is to making this very simple structure. And the way it works is every row in this table, this order fact table, corresponds to this business process frame. So when I insert a row into here, it means that someone has a line on the order. They bought this phone. And then maybe on the same order they bought this, but that's 2 lines. Right? 2 rows in here. Every time you add a row, there's foreign keys: order, product ID, customer ID, employee ID. These all go back to the dimensions. Many to 1. You don't add it unless you associate that order with an employee. Who sold this? Did the internet sell this? Or did Bob over there in the SU bookstore sell this? I want to know so I can track it. Then I can answer a real question: how many men sell water bottles? Because male or female, is a characteristic of being an employee. It's just an attribute in this table. I can say, filter on being a male, add up the orders. Got it. Again, I'm oversimplifying this. You're like, wow, we're going to go through this for another 14 weeks? It's much, right, Roshan? It's much more involved than this. But you need to understand it at this level before you can start to take it to the next level. That's the key. You got to understand it down here, then we're going to move up here, then we're going to move up here, then we're going to get to here, and you're going to leave it, and you're going to wish there was more, but then you know enough now to do it on your own, or to know enough that you hate it and don't want to do it on your own, one or the other, right? Okay. So again, you add this row, it gets a point in time. What date was that order, right? And then we can categorize that date. What month was that in? What quarter was that in? What year was that in, right? What's really cool about a date dimension is the date dimension is already defined. Today is a Friday. When I add the row to the date dimension for today, in the column, what day of the week it is, it puts Friday. It's always going to be a Friday for this date. No, it's never going to change, right? Anytime the power of the date dimension is any of your facts that need a date, you now can figure out easily if they happened on a Friday. Just by joining that to that. Pretty powerful. Then there's customer. So you get this in. At this point, there's no data in here, by the way. You just filled the schema. And this is where it's tricky, right? It's always hard to make tables without envisioning what the data is going to look like that goes in it, right? This is why we spent the first week learning to profile. Because as you profile, what you're going to do is build a query that's going to fill in these things, so that you have an idea of what the data is going to look like. It's not going to be in there, but now you'll at least know what these dimensions and fact tables should look like. And then you'll have something to build, something to go from there. Okay, now, after step 3 comes the hard part. Well, it's the easy part, then the hard part. The easy part is making a source to target map. This is a piece of documentation that explains where does the product dimension come from? Where does the order fact table come from in my data source? This is I'm trying to figure out where I can stand. Be in the middle and not be in your way. I can stand right here. This is where you... So if I go back here, I've got orders, right? That's my source data. I profile that to figure out these are the columns I would need in the table. I make that table. Now it's time to define how each of these gets filled in. And I do that with a source to target map. So this blue box here, this is not a very good source to target map diagram. If I ever made one like this in real life, I would get laughed out of the building. Okay? But what this source to target map does is it overlays the underlying schema with what is used to build the dimension or fact, right? You see that? Like the employee dimension is made up of these tables. And the product dimension is made up of these 3 tables. And then the customer dimension is made up of these, and the date dimension is made up of that 1 column. And you can see what's happening is we're flattening the schema out and focusing it around our business process. So if our business process was customers signing up for a mailing list, this might be the fact table. And then the dimensions would go out from there. But that would be a different what? That would be a different data mart, right? This is one data mart. That would be a different one data mart per business process. What we do. Now, there are exceptions to that rule, but as when you're learning as a student, one data mart per business process. Makes your life easy. So that's the source of target map. The hard part is figuring out how to actually take the data out of here and stick it in there. Now you might say, well, can't I just write a select something into this to do it, Mike? Yeah, there's a lot of, the first data warehousing effort I did, that's how I ETL'd it, with the SQL then. There's a lot of good reasons why you shouldn't do that. One of them is you don't get any, like if something goes wrong, good luck. You don't get any error handling, you don't get any job scheduling. You're going to learn that when we do this, which is ETL, which stands for extract, transform, and load, because you extract it out of this source, you change it around to meet your need, then you load it into that target. And while you certainly can do that with one SQL statement in this particular case, you're going to learn why there's a lot of reasons you shouldn't do that. And most of them have to do with managing the process and distributing the work to other people. There's actual software that you buy that does this. We will use something called SSIS, SQL Server Integration Services. But there's Informatica is the Cadillac of ETL. It's a tool that lets you pretty much take any data source and transform it into any shape for any data target, but it's mainly used in data warehousing efforts. So once you get all this figured out, and you have this, you might be saying, well, Mike, someone still has to write SQL to query this. You're right, they do. But you don't have to write SQL to query this. You can make a program that queries this. It makes it easy to explore. And you know why? Because every single star schema looks the same. It doesn't matter if it's zoo animals or orders. It's got a fact table in the middle and dimension tables on the outside. This is many. These are all ones. They all look the same. The fact that they all look the same means you can use the same tooling to explore all of them. And the tooling doesn't need to know what the dimensions and facts are. Only the human being that's exploring them needs to know that. And you can make charts and graphs and trends and histories, and you can explore them all on your own without the need to have some smart IT dude around to help you. And again, the reason it works, this is where business intelligence comes in. That's data warehousing. Business intelligence is the fact that we recognize that we can have software that leverages the fact that this is a consistent schema with predictable behavior, and then use that to put tooling on top of it to make this happen. Okay, I think I'm going to give you a demo. So you can try this demo. Don't try it now, but feel free to try this later on. I am recording this, so if you want to give this a shot later on, go ahead and do that. So in here, in this database, we have AdventureWorks OLTP, and there's a whole bunch of tables in here. Hold on, I gotta zoom out first and do it. And see, these use a schema. So you can see that there's person. There's all these tables associated with person, password, email address. Why would you have a password table? What kind of loony bat person made this database? Why would they have a password table? What's that? To retain the password later? Oh yeah, that's for storing it. But why not just store the password in the person table? What's that?
Multiple passwords over the time.
Multiple, one person, many passwords, right? There's also a good security reason for separating the passwords out, right? Right? Does everybody see that? Right? You're isolating it, right? So you can let people easily query people without having to expose whatever's in that password. Right? Normally we trick that. If the password was in the person table, I would make a view called vPerson, and I would give everybody access to the view, and I would hide the password column so they wouldn't see it. Right? It's the other trick that we use to do that. But there's a pretty good reason. I think the reason that they have password here is probably one person, many passwords, and they're maintaining the history of passwords. It's probably anyway, so look at all these tables in here. That's crazy, right? And then so we have our schema as well, right? You can look at this database diagram. But what I want to look at is this is where AdventureWorks is a great case study for you as a student, is you get the OLTP version and then you get the data warehouse version. So I installed both databases in there so that you can see how the same data relates in the way it was stored in the transaction system versus the way it was reshaped in the data warehouse. This gives you a good feel for how data warehouses go together. What you'll notice in the data warehouse is that there are no other tables than fact and dimension. Fact, dim, fact. The dims are the category tables, the dimensions, and the fact tables hold the quantities that we want to sum up. And so in the middle, each one of these is a data mart. Each one of those fact tables. There could be a situation where there's 3 fact tables in the data mart. But generally speaking, fact finance, fact call center, those are each individual data marts. And they share dimensions. Right? And so if I look at one of these fact tables, let's pick on call center. There is a date key, and that's a foreign key. Your foreign keys in your fact table, those go out to your dimensions, right? So if there were 10 foreign keys in here, there'd be 10 dimensions. This one only has 1. Now, what's interesting about this one is it has a date key, and then it has a date. And so you might say, well, why would I need the date in there if I have this date key that goes to a date table? I can just get the date there. There's actually a name for this. It's called a degenerate dimension. There's all these terms that you're going to learn. I struggle with whether or not we should focus on the terminology. And I think where the terminology is important is when you go into, you're having a conversation with your fellow data warehousing nerds. You want to say, well, that degenerate dimension makes a lot of sense because that's going to make our queries more performant. So the idea is that you put what is found in this table in here, you leave it in there so that you don't have to necessarily join it to the date just to find out what date it was. Right? Date keys are just some weird number that corresponds to whatever the date is. And so the fact that we leave date in here, you can still query this and get a date. Like, oh, that happened Thursday, October 7th, 1959. You get it without having to join it to this to find it. Leaving the dimension in here is called a degenerate dimension. These are all wonderful terms that you'll learn throughout the course. So let's take a look at internet sales. So if you look at internet sales, there's quite a few dimensions here, right? There's quite a few dimensions. There's product, order date, due date, ship date, the customer, the promotion, the currency. Did you buy it in francs, or did you buy it in U.S. dollars, Canadian dollars? Then the sales territory. Can you guys see this in the back? I got the zooming working. It's still too hard to see? No. Oh, you got it? Okay, good. And then this is a good indicator of the fact grid, right? Because this says sales order number, sales order line number. So that tells you one line in the order combined with the actual order number. Together, those form the key of the fact table. And by knowing the primary key of the fact table, you now know what one row means, right? What one row means. Okay, now, one of the things that this gives us, because this is amazing, right? But there was a time when this is all we had, and people were satisfied with it. And then eventually, as business intelligence grew, people realized we need some metadata with this stuff so that the end user knows to not add this column. I don't want someone to accidentally add that column and think it means something. Right? So, I don't know if I have a slide for this because I'm in the middle of a demo, but I will do this often where I segue in and out of things. It's probably here. There's this concept of OLAP, online analytical processing, and there's 2 flavors of OLAP. I don't have a slide for this, but I probably do next week. There's ROLAP and MOLAP. And ROLAP is relational online analytical processing. That's when you build a star schema out of tables. Okay? That was first generation data warehousing. Second generation where data warehousing has a ROLAP and what's called a MOLAP. And this is why you can't install SQL Server on your own computers, because to do the MOLAP tool, you have to be on a domain. It's got a tighter integrated security model. You can actually filter the data based on who's logged in. All that metadata isn't stored in the ROLAP schema, it's built into the MOLAP cube. You also, in the MOLAP cube, define hierarchies, like go from year to quarter to month to day. Drill down in that order. Don't drill down in any order you feel like it. I've defined a hierarchy of how you should drill down through the data. So there's all this additional metadata that we can use to make our dimensional models even better, but we need a different kind of database to support that. And that's called a MOLAP, multi-dimensional online analytical processing database. The next generation of data warehousing is this ad hoc data warehousing where you just give it a data set, the technology analyzes the data set, figures out what the dimensions and facts should be, builds a MOLAP for you, and then you're browsing it. And it like puts us all out of business. Problem is it's still in its infancy and it doesn't work very well, and it still needs intelligent people like us to help it out. But it is getting better, and I think there will be a day, when I'm long since retired, where it will be very easy to do business intelligence on your data, because the technology will do all of this stuff for you. All the things that you're going to learn, there'll be technology to do it for you. But you'll still need people like you, because there's always complex scenarios that can't, like orders, easy to do, but there's other business processes that are much more difficult or much more involved that the technology just won't be able to do. And also, you'll have to source the data from somewhere. That's not going to happen magically either. But the last week of class, we demonstrate some of these tools and discuss them. All right, let's get back to the demo. I jumped off. All right, so I have my internet sales here. What I want to do is I want to build, let's use a business intelligence tool for this internet sales. So what I'm going to do is I'm going to use Excel. Excel, you think of Excel, you put these formulas in and, you add this column to that column. But Excel is a lot more than that nowadays. It's, Excel, while it is a spreadsheet, it is a complete BI front end as well. And before most organizations even think of making a report for someone, a lot of times they'll say, is there a way that we could just do this with Excel and our dimensional models? Usually the answer is yes. With a little bit of training, right? Rather than taking some IT person's job and writing queries, with some training, you can empower users to answer all sorts of questions themselves. So let's get busy. So I don't know, you might have done this before, you might not have, but I'm going to walk you through it. You're going to see this again. This is also going to be in a lab at some point, so don't freak out if you're not getting it now, but you can also watch the video. But like I said, this will be in the document lens. So what I'm going to do is I got data here, my data tab, and I'm going to actually connect to my SQL server. Punch that in. And then I just use regular Windows authentication. Oh, hold on. I'm not logged in as me. I gotta forgot about that. Log in. Run as other user. Where are you? Come on. I just did this. What do I have to do from here? I'll try it this way. I can't run Excel normally because I'm not where's Explorer? Explorer. I'm not logged into this computer. Copy as path. It's because there's a link. I need to get to the actual Excel file. here's what's going on. You will not have to do this. Okay, this is all because I chose not to log into this computer when I came here. I'm not logged into this computer, so it's logged into a generic account. So when I run Excel and I try to connect to the server, it's like, hey, you're not Mike Fudge, you're some other fool. So now I have to log in as Mike Fudge so it knows which fool to use. Again, you can try to fake your laptop into doing this, but the domain model security is such where it won't let you do that. I tried that as well. One of the things I said was, can people install this technology on their own machine and then still connect to the data warehouse server? No, you just can't. All right, let's try it again. Data, sources, SQL Server. Don't need to put in a user password here, just hit that. Which database? Let's do AdventureWorks. Data warehouse. Now you might say, all right, you've already lost 90% of the users that I have in my organization. Here's the thing, IT sets up the spreadsheet, then you distribute the spreadsheet, via SharePoint or some web portal that you have. Then they just open it up and run it and use it. Hit the refresh button when they want to see new data. You establish the connection. Once you establish the connection, they don't need to do that. All right, we can set this up here. We want, what was it, internet sales? So this is the cool thing. When this is just a technicality. If I check that, right, and check enable selection of multiple tables, and then I hit select related tables, it figures out the star schema for me, which is actually kind of cool. Again, it's not rocket ship science to figure out the star schema, right? It just looks at all the foreign keys and goes backwards to the tables that are connected to that. Right. All right, let's see if this works. Let's do a pivot table to start. So who's used a pivot table before? So a pivot table is just generic beast that you can use to kind of slice and dice your way through data. But it is the ideal vehicle for dimensional models, even though in Excel you don't necessarily have to use them on dimensional models. But it is the ideal vehicle for dimensional models. So over here on the right side, I have my dimensions, and then I have, if I go down far enough, I have my facts. Now, one thing this does not tell me is which one of these are my true measures, right? Which one of these things are additive? It doesn't tell me that. This is the difference between rolap and molap. The rolap is pretty raw. It's just tables and, foreign key constraints. The molap, you can actually extend rules so that you try to drag this into an area and add it up and be like, you do that. Don't do that. That's some work. It'll tell you when. So let's do an example. So what do you want to know? Let's see. How many men bought in January? Let's try that. So let's grab sales amount, put that in my values. So there's my total sales amount. I don't kind of like that, so I'm going to actually format this so that it looks nifty. Number format, currency. That looks a little better, see that? What I want you to understand at this point is, I right click and do the number currency thing. If you're going rollup, you do that once, you never have to do it again. Then you give it to your users and it's all formatted nice and neat. If you're doing molap, you can set that inside as metadata for the queue they can build. And then that way, the instructions will come down when you're querying. So I've got that. Now, what did I want to do? I said, let's go by time. Let's find the time dimension in here. Customer is male, right? Customer gender. Let's put the gender in the row. Female, male. See that? And then I gotta find date. I wanted month, right? Did I say month? Month. Date dimensions are crazy to explore. Quarter, year. Oh, English month name. There we go. Let's put that in the column. There you go. So now I can look at this and say, oh, the best month. Let's see, the best month for men. I'm going to switch it so you guys can see it as well. So what I'm going to do is I'm going to move this into the column, and this into the row. And then I'm going to zoom it in. Looks like the best month for men was November. It's December. December. Oh, they're not in order. December. Okay. This is one of the problems, right? It sorts it ordinally. It doesn't sort it in the proper order. This is a problem. There's a rollup problem. Rollup solves this problem by you specify, even though it's text, you say, no, it's a month. So that's pretty cool, huh? Imagine us writing this. Imagine writing a SQL query which outputs this. Good luck. Good luck. It could be your final exam. Write a SQL query that outputs that. It could be your 659 final exam. Bam! Take you all day to write that, and then some. So here's where ad hoc querying comes into play. If you were to write this report for a user and give it to them in a spreadsheet, they would probably call you or email you or stop by your office and say, this is awesome, but I want to know, by year and month. And then you're like, oh, shit, now I got to redo it. No, you don't. If you did it this way, you wouldn't have to redo it because they would be trained and they would know how to add year to this already. And they would have exactly what they need, right? So let's do that. I'm going to go over here, and I'm going to find calendar year. And I'm going to add that under a row like this. And this is going to build a hierarchy. See that? Now it breaks it out by year and month. And I can roll these up if I want, like this. I can roll them up so that I see it by year. And then I can say, you know what, this looks pretty interesting. Why is it 29 million here for females? And I can click there and have it break out for me. And so, again, I don't need an IT person to do this. They set this up. It goes. And then you know what I say? I go, you know what? I need to see today's data. Just hit refresh. Just goes back. It requeries the MOLAP. I'm sorry, it requeries the rollup schema, and you're good to go. Refresh. Obviously, you can chart this, graph it, and it doesn't have to just be a grid. You can do this in a variety of ways. It doesn't necessarily have to be an individual grid. One thing that the rollup does not give you as well is you do not get, like, if I want to build a KPI, like, is this a good month? Let me take gender out of it. So I'm going to go back here, take gender, take it right out. So, is that a good month? I don't know. But if my business was smart and I had a KPI, I could say our goal for a given August is this. And then you can have another measure here that matches goal to sales. Then you can take the diff, right? You wouldn't have. See, this is where data warehousing and business intelligence evolve over time. You give somebody this, And then they're like, oh, you know what, I'd love to see this compared to coal, right? And so they do that, because it's just a spreadsheet, right? They can punch their numbers in there and do that. But what's even better is if you incorporate that into the data market. So that all of a sudden, you've got this column, and a column over here, and those are just facts. And one of the facts is, the difference between the two. And then they can do all sorts of analysis on that. So you can see how this is never done, right? Just when you think you've got it done, somebody wants more things. But that's what keeps us employed, right? Is that people always keep needing things, right? It's escalation. You give them one thing, they want something better. You give them something better, they want something better than that. It's cool. So there's drill downs. There's also ways to filter. Like I can take this data and just drill down or drill to. I can filter. I also double click on April. It's not. Usually it will ask me what I want to drill down to next from there, but I can't figure that out from the data. But I can actually go down to the day level if I want from that. But I can also answer a completely different question with the same set of data. I can say, oh, that's great, but what I want to see sales. I want to see how much stuff we sold. What product sells the best? Well, let's find out. I'm going to go back up here. I'm not going to use sales amount. I'm going to use order quantity. I'm going to put that here. I'm going to take that out. Then I'm going to get rid of all this time stuff, and I'm going to put product in here. Let's take product, English product name. And then I'm going to take this. I'm going to sort it. There we go. It is no coincidence that the 30-ounce water bottle, this is a total coincidence, 100% coincidence. The 30-ounce water bottle is the best seller. Now, every time someone does something like this, there's someone over your shoulder going, well, I only want to see December's numbers. I don't want to see all the sales. I just want to see this December. Well, all of these ways to explore these stuff, they have a filter. So I can go up here and I can pick, year, and then month name, month number of year. We'll pick that one. And then I'll go up here and just pick these out. I want 12, and I want 2014. Oh, there's none in 2014. I better pick 2012. There. And you can see now, let me sort them. Z to A. It is not the water bottle that sold the best in December 2014 or 2012. It is the Mountain 200. It's a bike. 46-inch bike, which I could never ride because my legs are too short. I'm pretty much down in the 30 and below. Any questions? Yes?
Professor, what if we send this report to someone who doesn't have an access to SQL database?
That's a good point. So like in the corporate world, what happens is we all log on to our computers, right? And, you can you'll be able to just bring it up and do it. But they have a solution to that. And in this tooling, every tooling is different. In this tooling, if you put this in SharePoint, right, you can log into a website, and you can actually use Excel in SharePoint. You can browse around in SharePoint and see these exact same things. And I can actually give you a demo of this because this is something that I use here. Hopefully it's not down, but what the heck? Let's see. Let's pick Firefox out here. It's you can't do this, but I can. I wouldn't want you to do it because it's got sensitive information. I'm going to have to pick and choose which one I show you. I'll probably stick to just the dashboard level. Hopefully Matt's not working on the SharePoint site because we've been upgrading it to the latest service pack. It's obviously slow because the caching isn't on yet. But usually it's much more faster than this. So if I go here, I go to let's pick course scheduling, and And let's pick syllabi. Let's see who's been uploading their syllabi to our website. You know, there's a place like, you know, you can see like the professor syllabi on the website, right? We track that. Like, we don't do anything about the fact that someone doesn't upload it, but we track it. We're actually positive reinforcers of that. What we do is we say, good for you, you put your syllabi up there. But we don't scold those who don't. So there you go. There's a report of that. Here's a trend of over the semesters. You know, this is how many courses we offer. This is compliance with syllabi. So you can see it's getting better over time. You don't get freaked out over this because you know, this is just this semester. It usually will fill up in time. And then this is a table of the same information. And see, I'm looking at this. I'm not using Excel, but it's in Excel. So that's how we do it. That's how we do it. There's also ways to do this on a tablet. They're just not available yet in the SharePoint we have, but that's going to be Microsoft's strategy for doing a mobile version. You can buy other products that are better than what the Microsoft tooling has. It's just, this is what we get for nothing. So
the broadcasting of the reports that you create in Excel, that is done through SharePoint?
Correct, yeah. And they are notified when these update. And this is actually an Excel sheet, but they can browse it in here. They can actually manipulate this data in here and refresh the data from within here as well. Most people just stick to this tab, and then the power users use this source data tab, which is a dump of the rollout schema that they can quickly slice and dice by term, but also go back and say, all right, well, this Deb Noski character, I see she uploaded her syllabi, but this Susan D, she did not yet. And I'm calling people out on the recorded lecture. I'm going to have to go, and this person, you know, no. But it's kind of cool, right? I don't know, am I on here? I don't know, maybe did I hit mine? See, mine's different because I posted mine online, so there's no real reason I'll upload it. Yeah. But you can go ahead and edit this work. Here's a really cool thing. This is a SharePoint thing. You can edit this workbook, and you can edit it in the cloud. I still don't need Excel to edit it. If I have a Mac, I don't have Excel, I can edit it right here. I don't give people permissions to edit it because it's a report. But I tell them if you want this and if you want to go beyond what I gave you, what you should do is you should take this, download it, then you can open it up in Excel and do whatever you want with it. But the data is still tied to the data mart, and the data exists only in the data mart. Like if I delete a row out of here and hit refresh, the row shows up. Because this is not rows in a spreadsheet. This is a link to a data source. It's a link to a data source. But this is kind of what business intelligence is all about, right? And there's better tools out there. There's some tools, you know, you can pay a lot of money for these tools, but they are awesome. Like one of them is called Tableau Public. And then it's just an amazing visualization tool. But it costs a lot of money. I thought about using Tableau Public in here. The issue is you can't do, with the size of the data I want to use, we got to pay for it. The free version only supports, you know, a couple thousand rows. I want to give you some real data. This is the challenge of professor. Do I give you glitz and glam tools, but weak data, or do you give them real data you can struggle with, but maybe not so nice tools? And I went with the other route, because when you work somewhere, you're going to have real data. The real data is going to be complicated. I want you to see complicated data. I don't want you to see so complicated data that you cry. That's not what I want. No crying in here, okay? So the data is complicated, but it's not so bad that you're just going to like completely give up. But you also got to remember, I'm your subject matter expert. If you have questions about that data, I'm there. I'm there. So that's an advantage as well, right? It's not like you're completely learning this in a vacuum. It's pretty cool stuff. Pretty neat. So there's ways in SharePoint to also display graphs right on this page that are summarized from the data as well, but that's a different tool. And we don't have that tool installed. That tool actually costs a lot of money, and we don't get that with our free version of SharePoint. There's another tool that Microsoft makes that lets you write an English query, and then it visualizes that query. It's called Power BI. I used to have, I think it was the semester before you took it, Roshan, I had a 25-user license of it, and I let everybody play around with it. What's amazing about it is you give it a data set, and then you say, in English, you say, give me total orders by product. And then you type that in. You type calculate total orders by product, enter. And then you know what shows up on your page? That. And you're like, holy crap, how did that just happen? Right? And then you try something else. You say, make a pie chart of orders by customer. And then it makes a pie chart out of it. You're like, holy crap. And then you try to do something that really is important and it doesn't work, right? Because, like I said, it gets you 60% of the way there, 30% of the time. That's about it, right? So, but that's why we're still going to be employed for a while, right? But that's it. That is the future of business intelligence. The future of business intelligence is you're wearing some kind of helmet, right? And you're just speaking, like Iron Man 3. You're just talking, and then it just makes a visualization and you spin it around your finger. That's the future of business intelligence. Okay? But you know what? You're still going to need data marts and dimensional models and all that stuff. That's the foundation. That's never going away. It's always got to be, right? The glitz and glam on top of it is what changes. So that's pretty cool. The one last thing I will show you is that you don't have to just use a pivot table. I know you can make charts and graphs, but there's another thing here called a power view. I gotta find it in here. Insert power view. Power view. Has anyone used a power view before? Used a power view before? Of course, you both worked. Didn't know you just did it for here.
We used it in the business analytics class.
Oh, really? Okay. So what class you took here?
Yeah, it was in Whitman.
Oh, it's in Whitman. So what Power View is, it's a high-level visualization tool. It's kind of like for building kind of like at the executive level. It doesn't have the same amount of detail as you would have here, but it doesn't necessarily mean it's. Oh, it's not enabled. Hopefully it'll turn on. Okay, so here's how Power View works. You get this pad. You're like, this is in Excel? Yeah, it's in Excel. So you get this pad, you get your stuff over here, and then you just start having fun with it. So let's go back here to internet sales. Let's see how much people were taxed. So let's grab tax amounts. That builds a basic grid for you. Then you can change that maybe to a matrix. And now I have rows and columns down here. See that? And then I can say, well, let's take, you know what a good dimension to use would be like their state, because that's going to depend on the tax. So customer versus state. Number of cars owned. How awesome is that? Let's see. How much tax do they incur by cars owned? Okay, so the people with no cars pay more sales tax than the people with 4 cars, which makes sense. This is a bicycle company. Okay, if you own 4 cars, you're probably not buying a lot of bicycle stuff. This actually brings up a really good point. A lot of times in the data warehouse biz, you want awesome columns in your dimensions, but you don't have the data. So what do? You give up? Like, like our SU system has a student table in it. But you know what it doesn't tell you? How many cars, it doesn't have a column in it that says how many cars you own. So what can I do about that? If that's important, if I feel that that's important to my business intelligence initiative, to know how many cars every student owns. Because I'm trying to figure out if this creative corridor thing work or connect the corridor from the members. Right? I want to know how many cars students have. And it's not in the student table, but I want it in the data warehouse in the student dimension. How do I get it there? How do I get it there? How can you find out how many cars a student owns? What would be the easy way to do it? Ask them, right? You make a survey, right? Fill out this web survey, right? Now, is everybody going to fill it out? No. but somebody might fill it out. Then when they fill it out, you need to have some way to associate the person who filled the survey out with the source data in the student table, right? Do you take the number of cars they own and add it to that student table? Changing the PeopleSoft table? Do it in another table. Then that table is a separate source, and both of those tables from those two separate systems form the customer dimension. See, in this example, the customer dimension all comes from AdventureWorks, but in life, that's not what happens. Some of our customer data comes from the web. Some of the customer data we get, actually, it comes from competitors or third parties that we pay to give us research data. Some of that data comes from our own systems, but they're not the same databases. They come from 2 or 3 different databases. So it's not always a situation that the dimension is cut and clean and all comes from one source. A lot of times it comes from several sources. And it gets updated differently over time. Like you might populate the customer, but I don't know how many cars I have. And then later on, when I find out how many cars I have, I go back and I add that. Add that later. It's called the type 1 change. These are all things you're going to do. Type 1 slowly changing dimension. It's all making more sense, you know? Yeah. You're like, I wish I could take it online. It's so much easier when Mike just talks for 3 hours, right? It's hard to have a class like this in an online format because while I could record myself talking for 3 hours, it's much more engaging to see your faces and see everybody, either getting or not getting what I'm saying and going off on tangents that kind of help explain it. In the online class, I did record what I did, but I'm talking to the wall. It's so fun. It's so fun talking to the wall. So, anyway, getting back to this, you can see how you do this in Power View. You can add a title up here, tax paid by number of cars. Boom. This is where it really gets into the, what I like about this is you might say, well, that's the dumbest idea ever. Tax paid by number of cars owned. Yeah, you're right, it might be dumb. But imagine how sucky that would have been if you had to write that SQL query only to find out it was dumb, as opposed to someone taking 30 seconds to put that together and say, well, that didn't tell me anything important, right? That's the value of business intelligence. It's not what you discover, it's what you discover that's valuable, and what you discover that isn't valuable, right? And the fact that you didn't consume a lot of time in that process. It's amazing how quickly this stuff queries in the star schema. And the star schema is designed so that it's very efficient to kind of slice and dice through that data. You can see as I'm doing this, it's just very fast. Very fast. And one of the other things that MoLab does at RollApp, again, we're using the RollApp. One thing that MoLab does is it will look at your dimensions and it will pre-aggregate those facts based on that dimension, because all these calculations, they're static, right? They're not going to change. The only way they change is if more data is added later on. So the idea is that you can pre-calculate, once you have the data, you can pre-calculate all the paths that someone might take through the data. And then that makes it really fast. And that's what tools like Tableau do. And that's what SSAS analysis services, which are it does that as well. Okay. So I'm running out of time because I spent way too much time on that, but that was like super fun. And I think that was really valuable. Did you not think that was valuable? And I think now everybody has a great understanding of how this all comes together, right? And turns into the class that you're going to be taking. Turns into the class you're going to be taking. So I'll leave you on this. So you got 2 textbook authors. They have different philosophies on what these things mean, right? And we'll spend the entire semester just going back and forth about how one person feels about this term and how another person feels about it. But what you want to know to start is that Inman is the founder of data warehousing. He's credited with coming up with this idea that it's important and necessary. And Kimball is the father of business intelligence. Okay, that. And then the $1 million idea of Inman is that corporate information factory, which is a reference architecture for how you build a data warehouse. A data warehouse needs a staging area. It needs ETL. It needs a global ODS. It needs an operational mart. An enterprise data warehouse. It needs data marts. People look at this picture, and this picture tells me a lot I need to know about how a data warehouse comes together. And we'll see this several times in this class. Kimball is, his idea was this thing called the Kimball life cycle, which doesn't architecturally explain how the data warehouse works. His thing is, what is the process that you should go through to do this? So in this class, we will learn the Kimball life cycle, his process for building a data warehouse, but we'll use Inman's architecture. Because I think he has the better architecture than Kimball does, and I think Kimball has the better idea of how to make it happen. His approach. His approach is very conducive to teaching students because Kimball's approach is to start with data marts and build it into a data warehouse. Inman's approach is start with a huge data warehouse and then break them out into data marts. And Inman's approach leads to a very, very structured and well-organized data warehouse. But it takes a long, long time to get there. The Inman approach, or the Kimball approach, gets you to a solution faster, but builds these little silos that you have to reconnect later on. Okay, so there's a little more work. It's definitely more iterative. Okay. So Inman's definition of data warehouse, strict, subject-oriented. Kimball is very loose. Anything that's queryable outside of your transactional system is considered data warehouse. What Inman says is that if you have data and it's not in a dimensional model, that belongs in your operational data store. So there's this database in the Inman model called an ODS, Operational Data Store. This is where your non-dimensional models go. So if you have staging data, but you need to keep other data and it's not in a dimensional model, it goes in an ODS. Okay? And the ODS is really, really important when you need to do things like drill through. Like maybe you have a data mart and you say, oh, that's an interesting order. I want to see the actual receipt of that order. That would come out of the ODS usually. Okay? In today's world, it might actually go right to the actual corporate application and you would get it there because there's not as much cost to querying these external systems as there once was. Okay, but when this reference architecture first came to being, there was a tremendous cost to actually querying your production transaction systems, like your ordering systems. Those could barely keep up with orders, let alone keep up with people that want to query the data that's in there. So that's why this ODS exists. Going back. And then last but not least, the approach, like I said, Inman's approach is you build this thing as a whole, okay, top down, and then Kimball's is you build it bottom up, small pieces at a time. And so we will actually do this Kimball approach where everybody is going to pick a project, but it's going to be really part of the same enterprise data warehouse. Right? You're all picking data sources on your project teams, and those data sources might be different. Somebody might pick remote labs, somebody might pick software download, someone might pick course scheduling, but it all comes from the same place, and it all belongs in the same data warehouse. So that's one of the advantages of the Inman approach is you can build these things in isolation, then together try to compartmentalize your dimensions, right? Because you might have student last name in your dimension, and you might not have student last name in your dimension, and then you have to figure out we need a conformed dimension that has all the attributes that we need. So those are the advantages, disadvantages. Here's the two books. Hopefully you have them by now. We'll use quite a bit in the beginning out of the Inman book, and then about a third of the way through the course, we'll be very heavy into the Kimball book, chapter by chapter. We'll go through everything. We use about 40% of the Inman book, the first 8 chapters. Okay, so I don't think I need to explain this because I've explained what this course is about now for 2 weeks. Okay, so I won't bother to do that. But what I will say is that we take a week-by-week approach to all things that are part of making this happen, right? You just got the 10,000-foot view. We're going to dive down to the 1,000-foot view and then recover everything in more detail. And you're going to see that there's a lot of pieces and parts to making this work. But it is a wonder when you get all this stuff together and working. And then we'll look at some other issues along the way, like data governance and master data management. These are all issues at a higher level that you need to address when you start building out your data warehouse. Initially, most people don't have concerns about them until they become problems like, what does a customer now mean? Now that you've got a data mart, you've got one, and you all have customer, to our enterprise, what does a customer mean? And who's going to control what each row in that customer dimension looks like? Where is it going to be sourced from, right? Because in the real world, your data is sourced from a lot of different areas, okay? Not just from one system. So there needs to be some governance of it. So to sum it up, right, here's our pyramid again. The top 3 layers of that pyramid, those are data warehouse activities. The bottom layer of that pyramid, that's operational, transactional database type activity. And that really sums it up. And then again, we have OLTP and OLAP, right? So I'm talking about relational OLAP right now. Just a star schema, denormalized, dimension and fact tables only, supports the analytical needs of the organization. Data mart is in the data warehouse. And one of the things I'll mention is, because I said the dimension and fact tables only, that's an Inman concept, right? He believes that the only thing that goes in your enterprise data warehouse are facts and dimensions. And if you have any other tables that support that data warehouse, those go with the operational data store. Now, in this class, you only have 2 databases. You have the stage and the data warehouse database. So if you have a table that's not a dimension or a fact, and it's not part of stage, you're going to have to stuff it in the data warehouse. You're going to have to go Kindle on us. But that's all right. In hindsight, is it really important to know those things? It is when you talk to other people in the business, because most people that have done this, learned under one of these 2 guys. I mean, it's only the last few years that we actually had courseware associated with this discipline. It's pretty new as far as things go. It's not nearly as mature as relational design, which is your 659 class. That's a pretty mature course. I mean, it's not much new and innovative that we really need to discuss in there. Okay. So, any questions before I let you go? Everybody knows what they need to do for next week, right? Okay, there's a problem set you need to finish. Okay, so make sure you do that. That problem set is going to get you intimate with the data sources that you'll use to do your project. So it's a win-win. I hate to say that. It's the world's worst phrase. I can't believe it just came out of my mouth. It's a lose-win, Eric. It's a lose-win because you got to spend time on it. It's a win because you'll learn something from spending time. I feel so much better about it. Okay, so have a nice weekend. If you have questions for me, or if I need to add you to the course for whatever reason, because you're still not connecting, I'm going to have you write your stuff down on this piece of paper about competency.